So that's why I was asking the question. There's about 22 voted. I have some, so I was answering how familiar are you with the topic. So whether you are an expert, you have a very solid background ataupun some basic knowledge. So mostly tak berani lah, the student tak berani nak jawab dia ada solid background, but they have some basic knowledge, which is very good lah. Okay, so what we're going to do today, sebab topik ni besar and it's overwhelming lah. Overwhelmingnya ialah kalau you tengok on the carboxylic acid derivative, and I wanted to show this one. We usually use this Masa Organic Chemistry website. Nanti kita boleh bagi dia. Nampak kan? This is the all the reaction that consists of the carboxylic acid and derivative. So if you look at this, there's around 54 reactions. So memang overwhelming. So I know some of you mungkin rasa macam dia ada basic knowledge, tapi dia macam tak pasti sama ada dia boleh jawab semua. So ensure you, it's really a very massive topic lah, I would say kan. I'll pass this to Dr. Hidayah after this. At least you boleh tengok ni macam rangkuman semua yang berlaku dalam carboxylic acid and their derivative. So usually we use this macam mind map fast kan, at least student daripada slide yang banyak tu is actually coming to this very few, just one page, but it's actually 54 reaction. Okay, so coming back like this is the stuff that Dr. Hidayah gave it to me today, that we wanted to focus on the nucleophilic acyl substitution today, and these are the three topic I think mungkin masuk exam lah kot So this is the only thing that I'm going to focus today: the reactivity of the carbonyl of the acyl group, the reaction of acid chloride and acid derivative, which do not need any catalyst because it's these derivatives are reactive, and we also have reaction of ester and amide that usually need a catalyst to memang perlu catalyst to undergo their reaction. So how are we going to do this? I'm going to do a very quick recap on this NAS. I panggil nucleophilic acyl substitution as NAS mechanism, and I will also extract the lecture notes daripada Dr. Hidayah. So at least bila I cerita ni, you guys kat mana actually there's the current slide you actually ada, and I just extract juga. And we're going to do a lot of problem-based learning lah. Macam dia bukan problem-based learning. Sebab kalau nak betul-betul problem-based learning, kita kena ada apa orang panggil different breakout room. Tapi kita just jawab saja kan. Hopefully you guys can bagi feedback lah kat I. Tapi itulah I pun trying to, tak berapa biasa dengan Webex kan. You can use Teams, tapi tak apa. It's okay kalau ada soalan, just boleh berhentikan saya. So of course usually we need a toilet break lah. Mungkin after 40 minutes or 35 to 40 minutes we're going to have our toilet break. Orang I boleh pergi annotate. So bila I tengok tadi the poll tu, how familiar are you with the topic, semua ada basic knowledge. So kalau kita tengok pada soalan yang pertama kan, which of the following is not a carboxylic acid derivative? I think most of you tahu amide is carboxylic acid derivative. Nitrile is also a carboxylic acid derivative because it's coming from the dehydration of the amide, anhydride and acid chloride. But ether is not a carboxylic acid derivative. So usually nitrile ni jarang diceritakan lah, tapi it's coming from the amide punya dehydration. So selalu kita dehydratekan dia untuk kita dapatkan kita punya nitrile. Kind of agent that you use as dehydration agent, selalu kita guna P2O5 sebagai. So in this case, which are not the carboxylic acid derivatives, is the ether kan. So kita mula pelan-pelan sikit lah macam takut agak susah. So from this, which are the following molecules are carboxylic acid derivative? Kita tengok yang pertama. Yang pertama ni apa agaknya kan, macam tak tahulah kan, dia macam amide, ester, adakah dia ester, adakah dia amide kan. Kalau kita kata dia ester kat sebelah, kalau kita kata dia amide, dia sebelah sini. Okay, so adakah dia carboxylic acid derivative? This is very clear, this is our nitrile, and this macam this is not our carboxylic acid derivative. So tiga tu memang confirm lah. Okay, kalau tiga confirm, kita boleh buang jawapan C dengan D. But here and this is also confirmed is our acid derivative, which is our anhydride. Okay, so from this we have one yang menjadi masalah. So adakah kita nak jawab 1, 2, all carboxylic acid pun lah. Adakah jawapan kita 1, 2, 3 atau 2, 3, 4? Macam 3 tu, sorry kenapa saya potong 1, 4, sorry. Okay, 3 tu pasti bukanlah kan. Okay, 3 tu pasti bukan. So apa yang ada 3 bukan our carboxylic acid. Tu tinggallah 1 dan 4 atau 2 dan 4. Okay. So jawapan ni kat sini bila ada macam ni, kita tahulah 2, 4. Because this compound is actually not carboxylic acid derivative. It's actually a carbamide. Okay. Tak ada dalam nota saya tengok tadi, nota tak ada. But it's not a carboxylic acid derivative because it's coming from a carbamic acid. Okay, it's a reaction between an amino acid lah, urea selalunya. So bentuk dia macam ni, dia, ataupun kita panggil amino acid lah. Okay, so dia bukan carboxylic acid derivative. Ni dia punya explanation dia. So carbon number 1 is not carboxylic acid because it's a derivative of carbon dioxide. Carbon dioxide is coming from the carbamic acid. Okay, so yang tu dah memang at least the basic knowledge yang semua orang tahu what are the carboxylic acid derivative. Okay, so sekarang ni kita nak pergi kepada the main mechanism of this acyl functional group interconversion, which is based on this nucleophilic acyl substitution. Kita panggil NAS. Okay, so this is coming from the Master Organic Chemistry website. Kita memang kita langgan dia kerana dia punya website dia daripada MIT Professor in Organic Chemistry. Cuma kita kena bayar lah monthly kan. So this yang I like about this website, dia memang tunjuk the summary of the reaction. So I selalu mula dengan summary with the reaction. Kadang pelajar rasa macam apa sebenarnya nak belajar dalam this topic kan. So bila kita kata pasal carboxylic acid derivative, is all lie down to this nucleophilic acyl substitution. Okay, this mechanism. So what are these mechanism all about is actually trying to make a new derivative from our carboxylic acid. Tetapi not a carboxylic acid per se, but it's actually on the acyl substitute. So when nucleophilic acyl substitution, usually you use negatively charged nucleophile. So we replace the leaving group with nucleophile at the acyl carbon, which is the carbonyl. We need a nucleophile because that is our base, base and our negative charge species lah. Okay, so when you have nucleophile there, nucleophile ni boleh serang kita punya here, dia boleh serang our acyl position because C double bond O are the carbon that are electrophilic. So bila dia berlaku, ini dia akan hasilkan tetrahedral intermediate, and the tetrahedral ni in order to form this pi bond, dia akan displace dia punya leaving group. So here is the X as a leaving group. Okay, so if we call it as substitution because the bond forming and breaking are on the same carbon. Dia macam main bola lah kan. The same team, tukar orang. Tak adalah pergi tukar orang kat team lain pula kan. So dia substitute player. Sama, dia bukan addition. Dia mesti substitute. And because nucleophile coming in, we call it nucleophilic. And at the position of acyl, we call it nucleophilic acyl substitution. Okay, very clear. Cuma bila kita bercakap pasal carboxylic acid derivative, we have to treat this reaction as an acid-base reaction. Ini yang selalu I perasan. Dulu I dah lama tak ajar this topic because this in Organic Chemistry 3. Because I'm a physical organic chemist, so usually I teach undergraduate and postgraduate level for kinetics of the organic reaction lah. So usually I ajar Organic Chemistry 1, tapi masa awal balik I have to teach Organic Chemistry 3, which is this topic. I perasan selalu ada masalah pelajar, dia macam tak tahu the basicity of the living group dan dia macam very confused with that lah. Okay, so I hope at least today kita boleh hilangkan confusion itu. So kita kena treat this reaction as acid-base reaction. So kalau kita kata acid-base reaction, when we say it's acid-base reaction, so the equilibrium will always favor the formation of the weakest base. So acid halide, which is our acetyl chloride or inilah acid chloride kita, are the most likely to undergo nucleophilic acyl substitution because kita keluarkan chloride ion, which is the weakest base, and our imide will be the least reactive species sebab dia keluarkan anion NH2 kan, is a very strong base. Okay, so again, this is the main thing of this nucleophilic acyl substitution. Reaction happen here at the acyl position. What are the species coming? The species coming is nucleophile, and you substitute the nucleophile at the same position of the carbon here. So that's why kita panggil dia acyl substitution, nucleophilic acyl substitution reaction. So there are 3 nucleophilic acyl substitution reaction. I don't want to go very lama lah pasal topik tu, but just a very quick recap kan. So at least maybe this will help you in your revision. So there are 3 usually nucleophilic acyl substitution that works very well lah. Usually kita tahu yang pertama ialah acid chloride lah, the most reactive derivative of all. Dia akan boleh hasilkan anhydrides. Okay. The other one is anhydride itself lah. Anhydride yang kedua paling reaktif. Bila you letak apa-apa nucleophile, like in here we have a sodium methoxide, will give you an ester. And the third one is also ester can actually be reduced by this debuff kan, diisobutyl aluminium hydride. Ada dalam your notes, tapi I'm not going to talk about the reduction today, but this is also a nucleophile that can reduce become an aldehyde. Okay. But the nucleophilic acyl substitution that do not work is these two. Okay. Kalau anhydride ni react dengan sodium chloride, you will not make an acid chloride. Sebab pelajar selalu rasa macam, oh, apa saja nucleophile boleh lah pergi serang. Tapi this reaction will not work. The same goes with ester. You ada nucleophile, you nak pergi serangkan, this will not work. Kalau you tengok balik apa yang berlaku atas dua tadi kan, yang ni, this did not work, ni work. Okay, yang tadi atas saya turunkan ke bawah. Yang muka smile ni work lah kan. So kalau you tengok tadi, what will actually happen is actually kita reverse sahaja dia punya identity dia. I will say something like that lah. Kita hanya reverse saja identity dia kan. Okay. Maksudnya tadi ke atas, these two kan adalah our nucleophile dengan our reagent. Tapi bila dia jadi produk, dia tak boleh berlaku lah reagent. Bila kita reverse dia punya identity daripada nucleophile, especially this one lah kan, mungkin this be a bit confused. Mungkin kita tengok pada this part. Okay, here it work well sebab ini nucleophile. Carboxylic ni sebagai nucleophile. Kalau carboxylic ni sebagai living group, dia tak work. Why? The same goes here. Okay, bila anhydride react dengan sodium methoxide, methoxide ni sebagai nucleophile, it work. Tapi kalau methoxide sebagai living group, it will not work. Okay, so it's not just simply coming, any nucleophile can come to the acyl carbon and the substitution, goes off macam tu, tak Sebab we have to again recall, that's why I just wanted to give the notion to you guys that about the golden rule of the acid-base reaction. So acid-base reaction will only proceed if you have a stronger acid and stronger base, and that will only, the reaction give off weaker acid and weaker base. Okay, you can see the favored direction because this is an equilibrium kan. So it will give you a weaker acid and a weaker base. And likewise juga lah, kalau you have a nucleophilic acyl substitution, it will always proceed like what acid-base reaction. So if you have a nucleophile which are strong base, you mesti hasilkan a weaker base. Cuma macam mana nak tahu weaker base? Adakah you kena hafal pKa dia? Kan sebab macam jenuh lah pKa. Tapi you have some idea roughly kat mana position dia, sama ada the weaker base or stronger base. We will give you the pKa, but no one's going to give you the list of pKa punya bacaan dalam exam kan. Tak ada, kita tak bagi dekat pelajar. Kita tahu, kita nak pelajar tak tahu somehow boleh position the pKa, where are the pKa are kan. So again, kalau bila kita kata macam ni, dia juga menunjukkan bahawa this nucleophilic acyl substitution only will be favored when the leaving group is a weaker base than the nucleophile. Nucleophile ni selalunya based, so base basicity is nucleophilicity juga, Okay, cumanya sebab di nucleophile selalu negatif, selalu pelajar selalu cakap as long as negatively charged nucleophile. Bolehlah buat reaction. It's not like that. Sebab itu juga is a good explanation why nucleophilic acyl substitution tidak berlaku kepada aldehyde dan ketone. Sebab dia pun ada acyl kan, kenapa dia tidak berlaku? Kerana you mengeluarkan hydride dan you mengeluarkan this another CH3 anion. So these are extremely strong base. So it's not going to happen. Kalau you bagi aldehyde dengan ketone, macam belajar ini reactivity apa aldehyde and ketone macam acyl juga, but it's not. Sebab tu aldehyde and ketone chemistry dia adalah chemistry yang berbeza. Dia addition kan, dia tak substitution. Okay, so these are the general rules for nucleophilic acyl substitution. I hope I can finish by 15 minutes in this first part. Lepas kita dah terus masuk reactivity di 3 benda itu. So general rule for this nucleophilic acyl substitution, if the leaving group weaker base than the nucleophile, then the reaction will forward. Itulah I cakap. This is the pKa table kan. I don't think any one of you going to hafal. Dulu kita macam alamak kena hafal ke, but it's actually tak perlu hafal, tapi you get some idea kan. Hydride is always a base kan, sodium hydride and calcium hydride, potassium hydride semua kan. Calcium ada potassium hydride kan. So they are extremely strong base. So nucleophile tak boleh nak ada ke nucleophile yang boleh displace these two? Tak. Okay. So sebab tu aldehyde kita will not undergo nucleophile substitution. And this is the amide kan, sebab you are displacing NH2 minus as the leaving group. Ni pun pKa about 40 So this is very high. And then if it goes down ke bawah, and you can see here, this is the weak bases. Tapi kat sini adalah in between is the moderately strong base where you have carboxylic and your hydroxide. Dia ada special case lah kan, kita kena tengok satu persatu. Okay, so itu my recap on this mechanism. At least these are the notion. If you can grab the idea of this nucleophilic acyl substitution, whatever reaction that comes in, you can actually understand. Okay, so the first learning objective yang kita nak capai hari ni, or we wanted to revise, is on the reactivity of carbonyl of the acyl group. So this is the main stuff, the part 1. So I extract balik kat mana, you boleh tengok balik reactivity of carbonyl of the acyl group ni dekat sini lah, daripada nota pensyarah. So dia kata juga relative reactivity of carboxylic acid towards nucleophile, this NS reaction is based on the structure and the nature of the attacking nucleophile. Macam kita cakap tadi lah, nucleophile must be a strong base. But other than that, kita ada juga beberapa kriteria kita lah. Nucleophile will also react better when you serang unhindered carbonyl groups. Kan? Of course lah kan, kalau dia besar macam mana dia nak ada, of course dia kena compensate with the steric effect and everything. So lagi electrophile carbonyl group tu lagi more accessible, the reaction are more reactive for the first step, which is the addition step. Okay, so if you ada a bulkier group, will become less reactive than the least carbonyl group with the substitution. Second thing that is so important in bagi rank in the reactivity of the carbonyl of the NS reaction based on the species is the basicity of the leaving group. Again, strong base will not be a good leaving group. Okay, sebab macam tadi kita dah cakap tadi, sebab you tak boleh going down, you boleh nucleophile ni boleh displace. Atas dia tak boleh displace. Kalau tak boleh, there's no reaction lah. Okay, as simple as that. And then kita dah tunjuk juga dalam your notes, the dimension is the weakest base and of course a good leaving group. In fact, chloride is actually -8 dekat bawah ni. pKa dia lah kan. Tapi I don't want you guys to kena hafal lah kan. pKa dia ni 38 kan. Tapi macam mana nak tahu kan, some idea lah, you have to get the idea back. So therefore kat sini ada satu very good table from your lecture note where how do you wanted to rank the activity is based on the leaving group. Okay, satu dah tahu derivative dia kan. The most reactive reaction is the acid chloride. The most reactive carboxylic acid derivative is the acid chloride sebab dia displace chloride. Less basic, again -8 macam tu. Second is anhydride. Dia buat carboxylate anion. and ester alkoxide and imide U. Carboxylic will never is a less reactive sebab you kena keluarkan O2 minus. So that is so basic, very basic than even your imide. Okay. And the third criteria untuk rank the reactivity of this carboxylic acid is the effect of the substituent. Okay, the effect of substituent. So kalau substituent yang melekat pada this acyl group are donating, so you tahulah dia memberi lebih banyak elektron kepada this acyl group, dia akan less reactive lah. Maksudnya you have to activate this carbonyl group sebelum dia boleh berlaku apa-apa reaction seterusnya. Tapi kalau the substituent is more electro-withdrawing, the carbonyl become more electrophilic because the electrons are being pulled away from this acyl group, become so electrophilic. So these are, I belum boleh tengok. Usually kalau lecturer kan, maksudnya masuklah to exam. Oh, these are the most important thing kan. Acid chloride is the most reactive derivative. You can see here, dia boleh tukar kepada semua derivative yang berbeza. Dia boleh tukar kepada anhydride, dia boleh tukar kepada acid, dia boleh tukar kepada imide, dan dia boleh juga reduce jadi carboxylate. Tapi to go up to acid chloride, you have to start with carboxylate lah kan. So anhydride pun sama, dia goes down ke bawah. Tapi dia ada mention kat sini reaction in the opposite sense are possible, tapi mungkin required more complex approaches, mungkin a catalyst or anything else. Macam tu. Okay, so kita pergi pada the first exercise untuk this. Okay, rank the following molecules in order of the relative activities, reactivity to the nucleophile in a nucleophilic acyl substitution. Kalau kita tengok kat sini, okay, we have ni silakan ester, anhydride, acyl chloride and imide. Kalau ni, okay, kita mula-mula yang basic-basic dulu kan. So the most reactive, of course, your acid chloride, and then goes to your anhydride and your ester and your imide. Okay, you have the explanation here lah kan. You boleh kata the most reactive molecules living group will be the weakest base. So pKa yang keluar daripada ester ni, sebab yang ni weakest base lah, which is chloride kan. As I mentioned, -8. So yang ni about 15.9. Ni ada more. Okay, star 4.76. Sorry, nombor 2 is anhydride because it's 4.76. And NH2 ni keluar sebagai 38. So of course, this is how you rank the relative reactivity based on the on the derivative itself lah. Okay. So kalau kita consider pula this reaction, okay, consider this one. This one is what? Secondary imide. Yang ni imide lah. And then you have your ester and this is carboxylate. So kita kena choose which is the most reactive and least reactive towards the nucleophile. Okay. Tak payah rank sekarang ni. Cari je mana the most reactive and the least reactive. Okay. So kalau kita tengok kat sini, of course lah, okay, acetate lah kan yang kat ujung is by far the least reactive kan, sebab ni lah paling least reactive kan, sebab kalau living group dia will be O2, oxygen, O2 minus kat sini kan. Okay, so daripada imide kat sini, ni secondary imide, ni boleh kata electrodonating group lah kan, lagilah kurang reaktif berbanding dengan NH2. So ni dengan ni, yang ni lebih menang, tapi ni dengan ni, of course this is the most reactive, this is the least reactive. Okay, so what kind of explanation that you can give? You boleh kata, of course lah, acetate ion here will be by far the least reactive because living here will have to be O2 minus. And imide here are poorly reactive sebab they extremely strong bases, tapi between these two, of course, dia lebih better daripada secondary imide. And therefore, the most reactive molecule here is the ester kan, sebab you ada dikeluarkan acetate. Minus OCH2 CH3, okay. Tapi dia taklah the greatest living group macam dia cakap sini, tapi of course dalam case ni dia lah yang paling baik, ester. Okay. Okay, sekarang kita tengok compound yang sama semua, which is ester kan. Sebab dia ada banyak cara kita boleh tanya you guys kan. Okay, you have this, phenoxide. kat sini and you have this. Okay. Consider the following molecules for a nucleophilic acyl substitution reaction. Sama. Cari the most reactive and the least reactive towards nucleophile. Okay. Mungkin kita boleh keluarkan dulu kat sini. Okay. Kalau dia nak keluar, dia akan keluar sebagai ini kan. Dia akan keluar sebagai cyclopentanoate. Okay. And this what? Ni pun sama. Ni phenoxide lah kan. Ni pun. Okay. Which are the like paling most reactive? Most reactive in other way is the weakest base lah. Okay. Most reactive is the weakest base. Lupa nak cakap. The weakest reactive is the stronger base lah. Tahu dah stronger base here. Definitely is this. Okay. Definitely is this lah. Kan dia macam kita punya methoxide tadi lah. This is the least reactive. And of course here is the most reactive lah sebab dia dah ada chloro and in fact dia ada another acyl. So these are the weakest base and these are the most. Okay. Sama juga So the weakest base here, the weakest base is here, which is the most reactive one. Okay. Okay, last question sebelum kita masuk kepada ni dan mungkin ada apa-apa soalan nak tanya is this last one. Sama juga macam tadi. Kan kita nak buat banyak-banyak nak tengok. Okay, this one. Ester. Semua ester, sorry. I should have not buat macam tu, sorry. I take this one. So this part. Ni, yang ni susah lah. Okay. By this lah, ni kena bagi 1, 2, 3, 4. Kita dah tahu dah mana yang paling tak reaktif kat sini kan. Which is our parents lah yang tak reaktif kat sini kan. Our carboxylic ni. Macam mana nak keluarkan dia kan. Kan carboxylic acid ada special case lah kan. Okay. Sebab once dia diprotonate dia akan jadi CH3 O minus kan kalau kita protonate dia kan. So again leaving group dia jadi apa? O minus. So extremely strong based and therefore a very poor leaving group. The least reactive. Nombor 4. Okay, nombor 3, 2, 1. Antara ni ester. Okay, semua ester. You have satu fluoro, satu kloro. Antara and then you ada acetate. Mana satu? Tak apa, kita keluarkan dulu kat sini. Okay, dia nak keluar, dia akan keluar sebagai CH2 CF3 minus OCH2. The other one pun sama minus CH2 Cl3. Kan? So antara ni semua sebab kita kata dia lagi banyak electron withdrawing kan berbanding ini memang rendah lah nombor 3 sebab tinggal ni dengan ni sama. Antara fluoro dengan kloro bila kita tengok kepada kita punya periodic table, of course fluoro are more electron withdrawing. So 1, 2, 3 dan 4. This is how you see of this reaction. Okay. So the most reactive is here will be the weakest base lah. Macam kita dah keluarkan tadi. Okay. So far okay ke? Boleh saya dapatkan reaction for the first part? Sekejap I will add to my webex ni. But I macam tak boleh tengok. Okay, boleh nampak. Okay, semua boleh. Okay, ada sort yang macam kura-kura tu I'm not sure. Boleh bagi reaction juga. Okay, okay saya tahu dia mencabar petang-petang ni kan. If you need to, minum air ke whatever ke kan, please do so. Okay. Ni adalah soalan kegemaran lah. Kita akan tanya ranking pada relative reactivity kan. Jangan fikir banyak-banyak dari segi apa, takut lah mas. Try to derive whatever that you know from there. That's why I try to put together your slide and what I should be delivered today lah kan. Cuma tadi tu I take from the lecture notes lah kan. The other way you can see nucleophile acyl substitution. Okay. Maybe we can go for the first break lah kot Okay, maybe kita break sekejap for 5 minutes and then we come back. Boleh Alright, kejap je tau, 5 minutes. So we'll come back for 07. So ada dalam 72 dah sekarang Alright. Okay Kalau kita boleh Mula balik. Okay. That's the only way I can use my iPad tu lah. The echoing if I open two devices. Alright. So that was the first part lah kan, on the reactivity kan. So sebab the PDF will only allow pretty well lah, rather than I annotate from the PowerPoint. That's what we discover lah during the lecture kan. So bila kita kata pelajar macam ada yang tak berapa suka kita guna PDF, but this is the only way we can do the annotation well. So the first part dah selesai lah in terms of the mechanism So now kita nak pergi pada the second part and third part. I hope we can finish by 5 or so tak lama. Okay, so this, but tadi kita dah tahu in terms of the reactivity, kita tahulah acid chloride and acid hydride kan somehow is the most reactive lah kan. Kan kat mana kita tengok? Kita tengok dekat dia punya jalur dia. Okay, dekat sini je kita tengok, dekat sini nanti, don't worry. Without the annotation of course dah macam-macam dah okay kat sini kan. Okay, so you can see here this is the most reactive acid chloride and hydride, and therefore kita buat this part somehow do not need a catalyst to do the reaction, and ester and amide, these two derivatives usually need some catalyst involved. Okay, so the second part will involve only the reaction of the most reactive derivative. So no catalyst. This is what written by Dr. Hidayah for me to do is on the hydrolysis, alcoholysis and aminolysis. So what I did is that I just, tadi you guys nampak from here, this organic chemistry summary sheet kan, you can see here kita tak macam mana you nak propose here, how do you want to prepare your acid kan. So kita nak fokus pada dua perkara ni dulu and the most reactive. Okay, so the preparation of acid chloride usually coming from the carboxylic acid that are reacted with SOCl3 lah, our thionyl chloride to get our acid chloride. So usually I like this reaction personally. During PhD I use a lot of this thionyl chloride sebab kita suka dia. It's the cleanest reaction. So you just give off sulfur dioxide gas sebab tu kita suka reaction tu, very clean reaction. Usually that tolerate and that's it. You evaporate, you get your acid chloride. And but somehow here thionyl chloride tu I find it difficult to get. Tak tahulah sebab dia kata guna and hydride juga susah nak dapat sebab dia guna untuk orang buat makmal sendiri buat dadah. So kita ni kena tulis surat kat custom lah, kata kita need this reagent for research purpose. But because usually if you beli the acid chloride tu easier lah, but it's more expensive to buy acid chloride here kan. So kita beli daripada kita beli thionyl chloride lah kan. Tapi susah sangat nak beli, kena tulis macam-macam. So this is how you prepare your acid chloride and you prepare the acid hydride. Okay, pretty much very simple for acid chloride kan. Dia macam just straightforward. You can also use PCl3 or PCl5. Okay, but for in hydride you ada dua cara whether you wanted to use sodium you base kan dia and then you react dengan acid chloride you, or you can actually heat the reaction. Okay, kita tengok nanti ada satu example in hydride ni boleh prepare melalui heat saja you get your anhydride. But what to do next is from this table, ini reaction ni macam table of reaction. So what I'm going to do, I actually cut this off. We just going to kita focus on the least reactive sikit lah. Tapi you will see it's not going to be the same like what your lectures notes are. But at least you jadi some direction for you to do your revision better. Okay. So kat sini kalau kita cakap pasal hydrolysis, alcoholysis, aminolysis, dia dah satu ni dah settle dah kita punya revision sebab we are talking about acid halide, which our acid halide kita. dengan anhydride, right? So hydrolysis kita ada dua cara, sama ada nak guna just water sebab they don't need catalyst you hydrolyzekan dia, but you have to add pyridine because you give off HCl, so you have to neutralize the HCl lah with pyridine. But pretty much very simple anhydride kat sini. Ada lain lah pula Kat sini first hydrolysis, just use water, you will get the same carboxylic acid. Itu yang saya suka. At least any benda yang pelajar kena tahu. At least hopefully by the end of the lecture you guys have more solid background on the topic kan. So the same thing anhydride pun giving off, bila you hydrolyze you akan dapat your carboxylic acid back. But it's actually can also undergo the hydrolysis using basic lah kan, dalam basic condition macam sodium hydroxide. But again you're getting the same compound kan. Kalau you tak nak guna base, sometimes you can guna just water. Tapi bila kita buat more complex reaction kan, reagent kita tu lebih more complex, sometimes you need more push from this base or acid lah kan. Okay. The second reaction is alcoholysis. Sama juga, your agent must be your alcohol. You react dengan acid halide you and anhydride you. Okay. Sini. So the second is alcoholysis. You masuk bila alcoholysis tu apa? You react with alcohol, you get your ester. Both sama. Again, because you give off Cl minus kan selalu, so you can add pyridine to neutralize the HCl. And your aminolysis, we wanted to make your amine kan, sama ada you nak guna ammonia, you nak guna primary amine or secondary amine, you get your amide. Sama saja. Okay. And these are more yang ni macam sodium lah, tapi actually give off kalau dalam the table is the reagent are much more different than the ones in your notes, and your notes is actually coming from this ammonia, secondary amine and primary amine kat sini kan. Tapi sama je dia bagi kat you the derivative of amide lah. Okay, depends on what other reagent are lah kan. Kalau you ammonia in excess, of course you get the primary, you dapat amide lah. Kalau is a secondary amide, kalau dia primary amine, you dapat secondary amide. Kalau dia secondary amine, you get the tertiary amide. Okay. So ini yang panjang-panjang dalam kotak ni adalah dalam from your notes. So macam mana yang saya cakap tadi, kalau dalam notes ni dia kata hidrolisis saja boleh hasilkan carboxylic acid. Tapi dalam notes kata mention, yes, the same. Okay. So dalam your notes, acid chloride ni dia ada 3 reaction. Yang pertama hydrolysis, dia akan convert your acid halide to carboxylic acid. Whether you wanted to use just readily with water, dia boleh form carboxylic acid. Sebab tu acetic chloride ni kalau letak dalam acid, you boleh dengar bunyi dia keluar very kan, sebab dia hydrolyze. Dia sangat reaktif kan. Hydrolyze kan dapat your carboxylic acid berasap sikit kan. If dia lebih degil sikit lah, kalau degil kan, steamy acidic fumes kan. Kita boleh add your acid or your base. Dalam base case ni kan tunjuk ke atas is our sodium hydroxide lah. The second reaction yang boleh buat daripada acid halide, of course alcoholysis lah. You react your acid halide with alcoholysis in the presence of pyridine because you wanted to prevent side reaction between HCl and your alcohol. Kalau tidak dapat haloalkane, and at the same time you juga nak nak neutralizekan your HCl lah kan. Kalau tidak HCl react with alcohol, always will produce a chloroalkane. Dia tak nak juga macam tu. Therefore, we usually use a pyridine. Sebab tu kita tulis kat dalam, sebab tu dalam kotak ni, you have to add pyridine. Okay, kalau you start with acid halide lah. And from acid halide juga, again sama, aminolysis where you get the table come from daripada the same notes, daripada the lecture notes juga, daripada ammonia, primary amine and secondary amine. Tapi I tak nak go through lah kan, bukan itu kita punya idea today. So the second reaction is acid anhydride juga. Okay, sama juga, dia ada hydrolysis, alcoholysis dan aminolysis. Hari ni kita tak nak fokus pada Friedel-Crafts acylation, just these three. Sama juga acid anhydride tadi dah tunjuk juga, which is this acid anhydride boleh buat hydrolysis in water, hydrolysis in base, dia boleh buat alcoholysis and aminolysis. Kalau kat sini guna sodium base lah, mungkin kat sini lah aminolysis dia. Okay, sama saja. Sebab tu saya perkenalkan dulu the nucleophile acid substitution punya mechanism tu. It's the same thing based on the addition and elimination of reaction. Sama juga hydrolysis of acid and hydride. It can actually undergo dalam water saja to give the carboxylic acid, but sometimes we need some push. We can also be carried out in acid or base, and again it will give you a carboxylic acid, and mungkin kalau dalam sodium hydroxide of course give you a carboxylate salt lah kan, kalau kita buat dalam basic solution. Tapi once carboxylate kita nak keluarkan dia, we have to add acid juga kan. Sebab itulah dalam table tu tadi kita nampak dia acid saja kan. Sebab how do you get carboxylate out from water kan? Of course you have to work out with acid. Okay, so this is alcoholysis, the second reaction of acid hydride to make an ester. Okay, so to make an ester kita tak perlu pun require a catalyst, sebab the anhydride itself is actually quite reactive to undergo this reaction. So what we're going to produce, we're going to produce an ester. Just a gentle heating lah, kita letak sikit reflux kat sini. So these are the example from the lecture kan. You can make your ethyl ethanol, your phenyl ethanol. And exactly again the same. Sebab tu kita panggil acid, carboxylic acid derivative, and it undergoes the same reaction. Sama juga with an excess of ammonia, you get an amide. With primary amine, you get your secondary amide, and with the secondary amide, you get a tertiary. Secondary amine, you get a tertiary amide. Okay. Alright. So kalau soalan kita bagi macam ni lah dulu guys, supaya macam tenang-tenang dulu kan. So kita tengok kat carboxylic acid. Dah tunjuk tadi dekat dalam table tu. Of course this is the thionyl chloride kan. At this time of course you kena dah tahu dah apa is going to happen. Just put back. Okay. Entahlah macam tu. And then this is your amine, primary amine U. Okay. Of course you're making your okay, salah ni. Okay. So predict the major product of the following reaction. Okay. So thionyl chloride will form acid chloride here from the carboxylic acid, and the amine will convert this acyl halide to amide or aminolysis. Okay. Boleh juga macam tu. Okay. And this pula kita ada acid chloride and kita nak react dengan acetic acid. Acetic acid, what will we get from here? Agak-agak kalau saya tanya ni mesti semua senyap je. Ada tahu dah. Tak apalah. Yang 2-3 yang hujung tu agak sukar sikit soalan, saya akan tanya yang biar jawab lah. So this acetic acid or ethanoic acid lah. So apa reaction yang boleh kalau kita tengok kat sini? Okay. Yang ni lah kita punya akan masuk kat sini. Okay. So you are making anhydride. Okay. Yeah. So bila carboxylic acid added to the acid chloride, the product will be your anhydride. Anhydride. Rasanya semua mantap lah ni kan. Very simple one. Okay. Okay. Anhydride react dengan amine. Jadi apa? Jadi amide lah kan. So, jadi amide and what? Kan kita kena tengok kat sini kan. Jadi apa? Okay. So kalau kita tengok kat sini. NH. Okay. Plus your carboxylic acid. Sorry, I lukis tu salah. Cepat Ya, sama lah kan. Okay. So this is the conversion of anhydride to N8. Okay, we dapat this reaction. Kalau selalu kita tanya produk kan, dalam list of question tak tahulah dekat UKM selalunya kita the first part B tu memang kita tanya semua-semua tu. And sometimes the part B tu kat kita tanya juga reaction and condition are needed to carry out the following reaction. So kat sini anhydride reaction, okay. Dia hasilkan ester dengan acid. Macam tadi juga, macam mana kita nak hasilkan anhydride dari ester and carboxylic acid. Macam mana cara dia? Okay. Ada idea tak? Mungkinlah tanya sikit. I kena go back to letak kat chat ke? Where do I see the chat now? I'll chat with everyone. Okay. Macam mana kita nak dapat anhydride ni? Kita dapat ester. Okay. Ataupun, okay, macam mana kita dapat ester? Tak apa, boleh sambil-sambil nak. Right? Okay. We are making an ester. And this is acid. So kalau ikut reactivity coming from acid anhydride, ester. So going down, selalunya kita kena buat apa? Kita tengok kat sini. Haji nak buka benar. Boring sangat This one I tak bagi this reactivity ladder ni. Kalau dalam dia tiba-tiba what is the numbers actually kan. So kalau kat sini dia pun cakap juga acid halide lah Acid halide can go to 14 apa? 14 ialah right? Anhydride yang jadi ester 17, 27. 17 and 27. Maksudnya dia kena react dengan sodium apa-apa ataupun dengan alkohol apa-apalah kan. Untuk dapat anhydride dengan nak jadikan ester. Dia kena, tetapi tak, confuse pula belajar. Sekejap. I don't want to go to that. Mungkin, yes, anhydride nak kena reduce jadi acid dan juga ester lah kan sebab anhydride kan. Dia katanya kat sini dah confusing. Okay, tak apa. Kat sini acid anhydride ni dia nak jadi ester. Okay, dah jadi ester. Apa kita kena buat? Kita pergi balik dekat notes kita. Anhydride nak jadi ester. Carboxylic acid. Okay, so kita kena react dengan alkohol, betul lah. Okay. Cuma ada dua cara kan. Dalam kes ni anhydride kita tak ada nama, kita kata dia is the ethanoic anhydride lah sama reaction anhydride kena react dengan apa? Kena react untuk jadi ethyl ethanoate. So ini dapat ethanoic. So these are alcoholysis. Tapi dalam nama lain dia juga kat sini. Okay, so you making ester. This is kita punya ethanoic anhydride lah ethanoic anhydride. Acetic acid and dengan ethyl ethanoate lah. Jadi ester. So dia panggil kat sini acidic hydrolysis but it's actually alcoholysis lah. Dia ada banyak nama kan. So macam somehow kita dalam case this website dia kata macam it's actually you putuskan the bond of between anhydride tu. Okay. So they call it as hydrolysis but in your notes which is also true is actually an alcoholysis Cuma ada dua cara. Sebab alkohol ini nak ada tak ada pun tak apa sebenarnya sebab dia reaktif. Tapi to get to better we put some acidic hydrolysis to make to apa maksudnya mencepatkan kita punya tindak balas with a catalyst. So acidic hydrolysis, ester and carboxylic acid. The other way if you just also can use sodium hydroxide for basic hydrolysis. Okay. Dalam notes you ada contoh phenol dengan ethanol as the alcohol. Okay, so that was the reaction for the two most active, the two most reactive carboxylic acid derivative. So dah habis dah part 2. Cepat kan, buat 27 minutes dah 20 minutes ya dah habis. So the third part is on ester and amide lah. And ester and amide yang kat bawah, reactivity yang di bawah. Okay, reaktiviti yang di bawah. Kalau kita tengok kat sini, have to see sinilah, here our ester and our amide. So reaction dia okay, kita nak tengok how do we prepare sebelum kita macam okay. So tadi kita dah settlekan how do we prepare our ester sebelah ni. So usually kita buat from acid ataupun dapat kita boleh buat daripada base dan kita react dengan our alkyl halide. SN2 you dapat your ester, ataupun kita buat Fischer esterification with alcohol in the presence of acid you get your ester, Fischer esterification. So for amide pula macam tadilah, you start usually you need to beat acid chloride lah. Dia tak boleh start daripada carboxylic acid. Okay, so they start daripada acid chloride, you put an excess of ammonia, you get an amide. That is how you prepare your amide. So this amide, okay, banyak reaction yang dia boleh undergo the ester itself. So this is the ester, this is the amide. Okay, dia tak boleh react dengan this carboxylic lah. There's no reaction sebab dia keluarkan lebih stronger base. There's no reaction. Okay, tapi ester boleh react dengan this sodium alkoxide ni, boleh macam acidification jugalah, tukar je OR dia, tapi coming from the sodium species. Ester are much more reactive than amide. You tengok amide ni lebih banyak reaction dia daripada ester. Okay, just for you to understand the table. So reaction dia yang boleh berlaku is hydrolysis. Tetapi hydrolysis dia dekat sini, kalau tanpa catalyst kat sini, terus dibagi reaction. Sama juga dengan alcoholysis. So dia tidak ada reaction without a catalyst. Okay. Okay. Okay, tapi for basic hydrolysis, you akan dapat ester, you akan dapat balik your acid and your alcohol lah. So dia dah bagi dah condition dia, what you need to do, you need to use sodium hydroxide and you kena tambah hydroxonium inilah species kat situ. The same goes to the amide. Okay. But from this dia tak capture trans esterification kan. So saya bagi je as a supplement. So you should treat this as a supplement. And if you go at the right hand side of this, you can see all the aminolysis reaction lah of this. Ester, hanya ester saja boleh react dengan ni sebab amide dah there's no reaction. So amide are the least reactive derivative of the carboxylic acid. You can see from here kan. Okay, ester saja. Okay. So you should assume more reaction are coming from the ester compound. Okay, the first reaction is making an ester lah. It's making an ester. So we go with Fischer esterification. There's 3 ways to make the Fischer esterification. As a revision, you should remember very well. We can use carboxylic acid with alcohol to make your Fischer esterification. Macam mana yang kita tunjuk dari preparation dia. And you can also start with acid chloride and acid anhydride because these two are the most reactive carboxylic acid. So if you use carboxylic acid, starting point there, carboxylic acid, you need to heat or reflux with the presence of acid. Usually we use sulfuric acid as the catalyst. So saya pun macam just nak extract this from your lecture note. So these are one of the most apa orang kata paling suka lah kita tanya soalan ni kan. This is such a very easy mechanism kan. Because the carboxylic acid is not that reactive, kita perlu activate kan this acyl group dia kan. Bila kita activate, kita dah tulis dah initiate esterification. So we need the acid because to initiate the esterification. Let me check kat sini yang the one that I extract. So this is how the mechanism masuk. I mean, my intention is not to detail out on the mechanism, but these are the how the Fischer esterification mechanism. If we start from carboxylic acid, you need to use a sulfuric acid to activate the acyl group. So kalau kita kata the conversion of a carboxylic acid to an ester, kita tahu is actually an esterification. Okay, ni soalan yang simple lah kan. Okay, tapi itulah okay, dia ada explanation kat sini sebab apa dia ni, sebab no CO bond are form of broken accompanying CH bond formation or breakage. Tak apalah. Dan ni dia kata bukan oxidation sebab tak ada CO bond broken or broken. Tapi kalau dia selalu pelajar macam confused sama ada oxidation atau tak sebab macam ada oksigen kan penambahan. Tidak ada penambahan pada spesies oksigen dia, so there's no oxidation. It's purely an esterification. Tapi rasa keyword confused So the second way to make your acid chloride, your ester is coming from the acid chloride. So again sama jugalah, tadi macam kita dah tengok dah pun. Dekat the first table tadi, then I go very quickly. Sini, ester. To make your ester kat sini, daripada acid chloride ion. Okay. So at least you tahu how to use the table after this. So kat sini making ester juga kan. Okay. Sebab tu dia kata you can start from carboxylic acid, it called Fischer esterification. You can also start with acid chloride and anhydride. Okay. This is where you have the, again, breeding is aided to prevent the side reaction between HCl and your alcohol. You don't want and haloalkene kat dalam your reaction and to neutralize the HCl being formed. Sama juga as anhydride pun sama reaction dia kan. Easy. So these are the Fischer esterification kat sini lah. Okay, Fischer esterification kat sini. Okay, carboxylic ester to an ester. So it start from carboxylic acid ni salah ni. So Fischer esterification, but I just wanted to show this is where you make an ester. Okay, so the Fischer esterification mesti datang daripada your carboxylic acid and your alcohol. Okay. Kalau kita tanya soalan ini, Fischer esterification between your pentanoic acid and your methanol, what will you get? Okay, what will you get? Okay, so kalau kita lukis pentanoic acid lah kan. So, dua. Okay, your pentanoic acid and your methanol. Pretty much right. You ada UH plus, right? Okay, so of course, then you're making your ester. Okay, 5. So you're going to be methyl pentanoate. Okay, so yeah, methyl pentanoate. Okay, saja je kadang-kadang soalan ni dia macam bagi ayat macam tu, macam kadang pelajar macam mana nak lukis methyl pentanoate tu. I'm sure this is happen quite a lot in UKM juga, macam bila bagi soalan je ni macam dia, tapi usually okay lah, but maybe take some time lah untuk jawab. Alright, so this reaction of ester, tadi dah habis sama macam esterification. Fischer esterification must come from carboxylic acid and alcohol in the presence of catalyst, iaitu sulfuric acid. Okay, reaction of ester ni dia boleh buat banyak reaction juga. Okay, hydrolysis, aminolysis and trans-esterification. Cuma ester ni dia less reactive toward nucleophile sebab dia keluarkan a much more moderate, not a weak base, a moderate base. So dia agak susah, agak tidak reaktif. Dan juga istimewanya ester ni dia ada cyclic ester lah, macam dalam notes dia panggil lactone, and whatever it is, it reacts similarly to the acyclic ester. So the hydrolysis and acid yang kita dah tunjuk dah pun akan hasilkan alcohol catalyzed by dilute acid, Acyl or sulfuric acid and heated under reflux. Kalau pure water ini is so slow. Sebab itulah kalau dalam you tengok tadi kalau nak convert ester tu dia tulis no reaction, tapi it's actually very slow. Mungkin you know you cannot, the kinetic reactions are so slow. It also can hydrolyze in basic condition. You akan dapat carboxylate salt lah. Ini tunjuknya. Okay. So ester dia boleh buat hydrolysis. Okay. Dia boleh buat hydrolysis kat sini. Dapat carboxylic acid and your alcohol. And kalau you guna base, sodium hydroxide, you get carboxylate salt. Again, macam I cakap tadi lah, you have to put back your Cl to get your carboxylic acid. Okay. Cumanya bila you ada base hydrolysis, dia irreversible lah. Product is much more easier to isolate kan. Kalau, okay. It's much more easier to isolate. Just put dia tu, you dapat 100%. Yang istimewanya ester ni, kita banyak guna base hydrolysis dia to make the soap lah. Okay, kan usually coming from the vegetable fat and you use sodium hydroxide lah kan. They are this important ingredient of the soap. This is our soap lah, sodium salt in soap. Okay, so again kat sini boleh tengok ester reaction, hydrolysis with water saja. Kita dalam table tu kata no reaction, tapi dalam your slide kata slow lah. So in terms of kinetic, macam in terms of perspective of kinetic, macam there's no reaction lah, so slow. But if you put in a base, kita akan dapat ni lah reaction dia. Yang kita panggil dia sebagai saponification. So hydrolysis of what two product, you get an acid and you get an acid and alcohol. Ni reaction dia. Okay, and alcohol. And the basic hydrolysis of ester kita panggil saponification. Yang ni selalu, I hope tak adalah siapa-siapa yang confused lagi from today's lecture. Hopefully buat tahu semuanya. Okay, so bila you ada ni, you are making this carboxylate and anion. Dengan sodium plus lah. Okay. So again, this is ester. You want to make the acid. Senang je reaction yang saya jumpa ni yang mudah-mudah lah. Tak sempat nak jumpa yang sukar-sukar gitu kan. So very easy lah. Basic hydrolysis or acidic hydrolysis. You boleh guna base, guna sodium hydroxide, and then kita tambah H plus lah untuk get your acid, or just water in the presence of acid. We call it acidic hydrolysis. The second reaction ester boleh pergi is aminolysis. Ni more to revision jugalah. So again, kalau you react with an excess of ammonia, you get a primary amine. Primary amine dapat secondary amide. Secondary amine, you get tertiary amide. Sama juga kat sini. Yang ni semua kita rangkumkan dalam satu table ni. Where was it? This is where. Kat sini. These are all the aminolysis. So you can see if you use excess of ammonia, you get amide, secondary amide and tertiary amide. Okay, very clear kan, senang sebab tu. So I said the table will help student a lot. Okay, trans esterification ni adalah macam nak buat ester, but another form of ester. Okay, dia hanya substitute and one alkoxy group for another in an ester. Dia sebenarnya dia boleh start pada ester lah, tapi kita nak tukar salah satu substitution dia kepada another alkoxy group. Okay, so this is a way where we can actually form more complex ester. And dia ada mention kat sini from your notes, it will happen acidically and basically. So usually kita perlukan kita perlu acidic conditions, but again alcohol is a very weak nucleophile, not a strong base ataupun not a strong nucleophile. So kita perlukan dulu, kita perlu activate kita punya acyl group or carbonyl group. So become more electrophilic for the attack to occur. But in this case, kita perlu pastikan kita guna excess of alcohol to drive the equilibrium in the forward reaction. Tapi dalam ni dia tak ada mention. Sebab kalau you tengok kat sini, there's no trans esterification without a catalyst. Kalau tengok kat sini kan dalam notes tu, ester Kalau alkohol lah, this is actually transesterification lah kan. Tapi no reaction dia kata. Sebab kita tak mention kat sini apa-apa acidic or basic. Tapi it's actually, it could happen if we have acid or base condition. Just for you to remind. Just to, bila you revise the notes, because dia tak ada catalyst, H plus or H minus. Yes, you can make your transesterification. You can see from it needs like large excess. So mungkin kena tambah kat sini, notes kat sini. Maybe you have to use large excess alcohol with the presence of acidic. Sebab alcohol tu again a very weak nucleophile, you perlu activate your acyl group. And you can also do the same with your cyclic ester, your lactone, to make transesterification lah. Cuma yang ni dia putuskan lah kan. Untuk dapatkan your, but you get, I mean at the end of the day you get another ester lah. Okay. So these are the mechanism in acidic condition which I don't think I wanted to highlight more detail kan. Cuma this is where you need the carbonyl lah again before the nucleophile can attack. Cuma kalau nucleophilic, kalau alkoxide tu dia boleh attack lah. It's much more easier the mechanism. You don't have, because the nucleophile from the alkoxide are much more stronger, kan? So dia boleh react. Okay. So kalau soalan yang ada yang saya boleh jumpa lah dalam masa yang singkat hari tu ialah dia ada dua reaction. Kalau kita tanya lah, which of these two transesterification under basic condition will be more favored? Dia tanya macam itu pula kan. Dia tak ada mention pasal acidic condition. Okay, so maksudnya incoming nucleophile ada dua jenis lah. Okay, which will more favored? Mana yang lebih more favored kan? So kita dah tahu kalau kita nak buat transesterification, kita nak tukarkan this kepada whatever this coming lah kan, dengan this alkoxide group, our nucleophile ni. Kita kena tahu the coming nucleophile tu must be a strong base. Betul kan? This is our negatively charged, which is our nucleophile. It must be a strong base. Okay. So di antara dua ni, macam ni kita nak jawab soalan ni, kita kena tengok lah antara dua ni mana yang lebih bagus untuk kita tukarkan. Sebab yang dia akan keluarkan these two stuff kan. These two stuff. Okay. So stronger base, kalau kita tengok kat sini, beza dia kat hujung saja you ada CH3 and CF3. So by having more electronegative element group kat situ, our trifluoro methyl kat situ, it make you a bit more weaker base. So jawapan dia adalah yang pertama lah yang lebih, yang pertama lah yang lebih favored. Okay, kerana this one is much more favored. Okay, kalau kita tengok kat sini, kita boleh tengok yang ni the stronger base, a weaker base. Ini yang kita nak daripada mana-mana base reaction. This is a weak. But how can a weaker base displace a stronger base? Transesterification will favor the first react. Okay. Or dia ada juga lah kata, okay, yang kita keluarkan tu the conjugate base of ethanol, which is di yang bawah tu dia unfavored sebab pKa dia 15.9 kan, tapi siapalah nak hafal kan the conjugate base of ethanol 15.9, but we can actually look at this CF3 much more weaker base than the CH3. It's easier like that. Okay, and finally on the amide part, okay, amide ni dia tak berapa reaktif kan, cuma you can see lah dia boleh prepare daripada like acid lah, carboxylic acid, acid chloride, boleh coming from here, acid anhydride and ester. Dia yang reaction dia yang cover today is based on hydrolysis saja, yang lain kita tak nak cover lah. But this tadi pun kita dah tunjuk sikit lah how do you buat formation of nitrite. You can dehydrate dia guna P2O5 kan. So hydrolysis dia simple saja, water, okay, tapi mesti ada acid dan mesti juga ada or basic lah, condition sama saja. If you use water, in the presence of acid, you get carboxylic acid, and in the base, you get carboxylic salt. So here, kalau kita tengok kat sini, okay, kalau kita tengok kat sini, hydrolysis with water saja, without hydrolysis with water only, there's no reaction. Dia tulis siap-siap dah. There's no reaction. Kalau hydrolysis with base, ada, you dapat acid. Tapi actually, kalau ada acid, boleh dapat carboxylic acid. Okay. So soalan dia, which of the following compound is hydrolyzed to propanoic acid upon heating an aqueous sulfuric acid? Mana? Yang ni macam kena lukis lah satu compound kan. Propyl acetate ke, N-methyl propanoate ke, ethyl propanoate ke, OA and B. Okay, macam susah. Kita lukis dulu satu-satu kan. Ethyl propanoate. Okay, bolehlah juga propyl acetate. 2, 3. Okay, propyl acetate. Ni propanoic acid lah Oh, hebat kisan. Sorry lah petang ni. Mengharapkan saya punya Apple Pencil masih bercharge. Okay, so soalan dia from this propanoic acid. Which of the following compound is hydrolyzed to this propanoic acid upon heating in aqueous water lah Apa following compound tu you dapat propanoic acid? Adakah propyl acetate, N-methyl propanamide? N-methyl lah ni pun macam revision untuk apa orang panggil nomenclature. N-methyl propanamide. Okay, N1, 2, 3. Ethyl propanoate. Ethyl propanoate. 1, 2, 3 This is ethyl. Kalau kita tengok kat sini, N-methyl propanoate. Adakah kalau you hydrolyze kat sini, you dapat tak propanoic acid? Yes, propanoic acid. Propyl acetate tak boleh. Propyl acetate dia macam mana you nak buat? Tak boleh. Okay, propyl acetate tak. So jawapan A dengan AB ni dah boleh betul. So dah tahu dah lah jawapan dia apa? BMC. Seperti propanoate pun sama. You hydrolyze kan you get your propanoic acid. So this is how we do it. So to get a propanoic acid hanya 2 saja, N-methyl propanamide. Kat sini you hydrolyze ethyl propanamide. So you get the same propanoic acid. Kat sini lah NH. Alright. Okay. Soalan yang seterusnya. What type of compound is produced in the reaction between cyclopentylamine, cyclopentylamine, methyl ethanoate. This is ethanol. Methyl ethanoate. Methyl ethanoate. Itu 2 Apa yang you dapat? Sila you dapat amide lah kan. Senang sangat soalan ni kan. Okay, so what you get an amide. NH with this. Okay. Ni pun dah lukis dah. Alright. Ada berapa lagi soalan yang sukar-sukar? Ada lagi 2 soalan. Yang ni bagi last. Yang lepas tu kita nak suruh pelajar bagi jawapan kat saya lah. Okay, ni anhydride. Okay, tapi kena tengok juga kat sebelah ni ada apa. Sebab saya perasan dalam notes tu ada pasal enol. Okay, tapi tak apalah. Fokus pada tu. Okay, ni adalah so kita cuba tingkatkan sikit kita punya kesusahan kita. Tetapi apa-apa pun just focus on this. This is an ester. Okay. Tapi not really an ester lah kan. Sebab dia boleh jadi enol. Okay. Dan dia react dengan primary amine. What will you get? So kalau mudahnya reactionnya, kalau kita nak tengok kat sini, tentunya dia akan dapat amide lah. Kan? Tentunya dia akan dapat, sorry. Lupa nak tekan tu. Okay. So dia akan masukkan this ni lah kan. Carbon O, NH CH 3 kan. Okay. And S4 lah 1, 2. 1, 2, 3. Yes. Okay. Dan apa kita dapat balik as simple as that lah kan. Ni macam just amide reaction. Akan dapat this. Okay. Tapi apa yang berlaku di dalamnya sebenarnya, okay, nampak simple lah kan kat sini. Cuma ni adalah enol. Tapi dia boleh berlaku addition, elimination macam biasa. Okay. Elimination and elimination sebagai biasa. Tapi sebenarnya dia macam addition, elimination plus ketoenol tautomerization. So this part akan react with this part. Okay. So you akan dapat this proteinamine. And dia akan jadi enolate lah for this enolate. Okay. So dia pun acid base reaction sebab main ni. And dia akan jadi amide kat sini and you dapat this. So bila ada ketoenol tautomerization kan kat sini dia lebih selesa. Oh sorry, saya jawapan pun salah. Jawapan saya tadi kan dalam enol lagi kan, tak stable. Okay. So sepatutnya dia akan jadi ketone tautomerization. Tapi apa pun kat ujung ni is the amide. Okay. So kita cuba buat soalan ni lah. Pelajar cuba buat, saya bagi masa 5 minit untuk buat. Okay. So dekat ni you boleh nampak dicarboxylic acid. You heat, you dapat apa? You react dengan amine. Satu amine pula ammonia, what will you get? And the end of the day you are getting this compound. Okay. So cuba buat dulu and beritahu saya produk satu ni apa. Saya dah nak habis dah. Banyak sangat jawapan. Okay, supaya pelajar boleh buat pula produk satu apa, produk dua apa. Tunggu dekat chat.
Okay, Dr. Izzaty. So, actually Webex ni kita sampai pukul 5. Tiba dia terus stop.
Oh, okay. Okay. Kalau macam tu tak apalah. I habiskan. Bahaya. Okay. Tak apa.
Banyak bagi soalan ni. So, I think before we end our
Okay. So, tak guna.
Tak apa Daya, okay.
Okay, kan?
Okay, I dah double check. Okay, boleh. Dia tak auto stop.
Boleh.
Izzaty, boleh proceed.
Okay, boleh tanya a few soalan, no problem.
Okay, at least saya dah bagi banyak soalan tapi yang ni bagi pelajar buat lah. Yang lain semua macam very straightforward. Cuba buat produk satu apa, bagi nama je.
Tadi ada suruh dah student I kena tanya soalan dan bagi jawapan.
Ya, betul. Boleh soalan.
Produk satu what you get daripada carboxylic acid. Sebab tadi dalam the main tu kan dia macam susah sikit lah. Tapi yang ni kita paling banyak guna lah reagent ni. I use a lot of this reagent during my PhD. So saya suka soalan ni lah. Yang boleh dicarboxylic acid, you heat saja, what do you get? Sebab you kata kalau ada ammonia tu mesti jadi at least produk 2 tu mungkin amide lah kan. Sebab lepas amide you dapat ni lah cyclic amide lah. Kan? Sekejap, saya panggil je lah nama. Saya tak cuba jangan saya sekejap ya. Oh, okay. Aisyah ada. Aisyah adalah nama yang paling ramai di UKM. Nama kedua ramai adalah Izzaty. Anyway, Aisyah, do you have any idea what are you making from the first step tu? Datang balik kat sini. One. Sorry lah Oh, Aisyah tak ada kat situ. Dia pergi solat asar. Dia kata bagi banyak soalan. So saya macam okay. Spend more banyak soalan lah. Rasa Aisyah tak ada tu. Okay, siapa nak panggil lagi? Terus kurang. Amalia, are you there? You maybe ada Izzaty. Tak ada Izzaty kat sini. Lelaki lah, lelaki boleh. Amalia pun tak jawab. Amir Faris bin Ahmad. Oh, I can say the full name. Tiba, sorry lah, tak biasa dengan Webex. Amir, ada idea what you making? Bila you ada dicarboxylic acid, you heat saja. What will you make? What will you form? What will you make? What will you formed? Dia semua takut lah, saya rasa tak apalah It's okay, it's okay. Dekat dalam this sheet, okay.
Ada soalan untuk diajukan pada Dr. Izzaty? Do you have any question, student?
Soalan. Semua
ada tak soalan daripada
tak apa, it's okay. I share apa? Ada ke?
Ada tak? Nak slide lecture boleh? So nanti Dr. Izzaty, can you share your slides?
Boleh. Of course. I will share the slide and the summary sheet, don't worry, okay? So actually it's coming the carboxylic acid, dicarboxylic acid saja kita bagi soalan yang susah hujung tu. Sebab dia ada di summary sheet where the acid bila you heat up, you are making anhydride. Okay, so it's the same here. So the product anhydride. And anhydride react with amine, with ammonia, you'll get product tu lah kat sini, okay? So it's actually this part. This is how you prepare an acid hydride. Some acid hydride can be prepared just by heating the carboxylic acid. And this is what we call a malic hydride. Malic anhydride ni I guna lama lagi contoh ni. A malic anhydride, this cyclic anhydride. So what is actually happen, okay. So ini ada OH double bond OH. Allah tulis tulisan. Dah besarkan sikit tulisan I. Okay, ni 1, 2, 3, 4 OH 4. Okay, 1, 2, 3, 4 So bila you heat saja, you take off water out. Sebab tu water, what you get this cyclic anhydride or malic anhydride. Bila malic anhydride ni react with ammonia, one equivalent lah kan. So dia akan ambil sebelah saja. Sebab tu kita tulis kat sini 2 equivalent ke apa equivalent dia. So dia agak sukar sikit lah soalan ni. Sebab tu saya letak di hujung. Okay. Tapi actually because it's so symmetry kan, malic anhydride is a symmetry molecule kan. So it doesn't really matter lah dia gerak, dia bertindak balas di mana sini ke, this part kan. But only because you supply only one equivalent, you're going to substitute only one of the acyl group lah. So you're making an amine, but the other group masih lagi carboxylic acid. So bila the other group masih lagi carboxylic acid, therefore bila you heat the reaction between this kan, you put them together, sama juga macam atas ni, cuma sebelah tu is an amine, sorry 3, 4. Kan? Keluar juga water and you get the cyclamide. Okay? Itu je lah. Saya tak suka. Okay. Last question before we ended our class lah. You are the lactone. Okay. And acyclic ester. You hydrolyze lah dia kan. What will